Alright guys, in this video I'm going to cover 4.3 section from the book, which is Riemann Sum and definite integral. Okay, so how did we do in the last class? To find out the area under a curve is basically we divided the interval AB into n equal parts in the last time, but here I want to divide into n parts, but some of them may be very small, some of them may be very big. So why did we do that? Because see, on this in this region basically you don't have to have a very small interval, because even if you have a big interval the function is not changing that much, right? The function is almost, the graph is almost the horizontal. In that case, even if you take a big interval, the area under this piece and the area of the rectangle will be the same. So you don't need to have a small pieces here. But when the function is changing rapidly, you may need very small pieces to take care of when we find out the area of the rectangle. When the rectangles are very small width, are of very small width, in that case that will do better job than making a big rectangles here, right? So what we do in next is we will divide the interval AB into small sub-intervals, but we don't need the equal width. So some of them have very small width, some of them have the big width. So what we denote is we denote by norm of delta. This symbol is called norm, okay? So this is called the norm. Norm of the delta is the width of the largest sub-interval. So in this figure, this is the largest sub-interval, right? And I denoted that by delta, norm of delta. Okay, so what is the area of the area under the curve above x-axis here is, so this is the area, sum of the area, right? Sum of the area is I'm picking CI. In each sub-interval I'm picking CI. CI can be left side height or right side height, or we may pick CI somewhere here and then find that as the height. Okay, so f of ci times delta xi is basically width of each of the subintervals. So delta x1 is the width of the first subinterval, delta x2 is the width of the second subinterval. Before we have delta x, just delta x, because we had all those subintervals had the width delta x, same width, right? But we have now different width, that's why you do delta xi. So you need to find out width of each of those subinterval and then find the height, and then this multiply the width times the height to find out the area of each of those stripe, okay, and then add them. But what we had limit here is limit delta, norm delta tends to 0, means if the width of the largest subinterval is 0, meaning if that is very small, meaning all of them will be very small width, right? In that case, when the width of each of the subinterval are very small, in that case this sum will give you the area. That's similar to the previous concept, right? Now we define the definite integral. Okay, definite integral is a to b f of x dx is defined by this sum. Okay, basically this definite integral is basically the area under the curve fx above x-axis between a and b. Okay, so why? Because this is defined as the limit, norm tends to 0, the sum of the area of the rectangles. Basically this part gives you the area under this curve, right? So we define that as the definite integral. Okay, so this is the definite integral of f of x between x equals to a and x equals to b. We call this as lower limit of the integral, and this as the upper limit of the integral, upper limit of the integral. Okay, now here f of x is called integrable. Okay, meaning the integral of f of x exists in the interval ab if the limit on the left side exists. If this sum and the limit exist, then we call that fx is integrable in the interval ab. This is the definition of definite integral. Again, this is called the definite integral of fx between a and b, and fx need to be continuous to have the definite integral. Okay, so this is just the concept, how we define a definite integral. Now what we do next is the some properties of the definite integral. The first number one property is, if you find the definite integral of a fx from a point to itself, then it is 0. Meaning, here we are finding the integral between a and b, right? But if you find out, that is given by the area under the curve. But if you find out between a and a, then that will be the area under the function fx above x-axis between a and a. So there is no area, right? In that case, the area is 0. That's why the definite integral is 0, right? So basically you can say area is 0, right? Now next is, if you are finding a to b fx dx, that is same as negative of b to a. Just the direction change, right? So area between a and b under the curve above x-axis is same as area between b and a under the curve above x-axis with negative sign. So this is just the direction will be opposite. Okay. Number C. If C is in the interval a b, so what does it say is, suppose you have, let's say there is a, there is b. Suppose there is a point C here. Okay. So what it says is, in that case, and fx is integrable over ab, there are double and fx is integrable over ab, and we can say if, basically. So if C is a point between a and b, and if fx is integral, meaning if this area is finite and if this area is finite, right, then what you can do is a to b fx dx, a to b fx dx can be divided in two pieces. You can find out a to c fx dx, you can find this area separately, and then plus you can find this area separately, and then you add those two areas to find out the total area. That's what it says. Okay, so what it says is a to b fx dx equals to a to c fx dx, that part, plus a to c to b fx dx, this part. Okay, so this is f of x function. Next, if you are finding a definite integral of k times fx, you can pull that constant out and find the integral of fx dx between a and b. Next is, if you have sum of the two different functions or the difference of two different functions between a and b, then you can distribute the integral. You can give this integral to this one separately, and then plus give that integral to that one separately. Basically, we are distributing the integral to both f of x and gx if there is a sign plus or minus. But if there is times in the middle, we cannot distribute that way. Only if there is plus or minus sign. Let's do this example here. If negative 4 to 0 fx dx is 21 and 0 to 4 fx dx is 5, find 3 times fx dx but between negative 4 and 4. What it is asking is, suppose this is negative 4, right? This is positive 4. Suppose there is a graph like this and then like that. Okay, so what is given is this integral, this area is given as 21, right? And this integral or this area is given as 5. So this is 5, this is 21. Now you have to find out what is the integral of this whole function between negative 4 to 4 and multiplied by 3. So the solution is, we have integral of 3f of x dx between negative 4 to 4 is equals to, let's take 3 out and then do negative 4 to 4 fx dx, right? But you can break this by using this property, right? Let's use that property, and then you do 3 is outside, but what I'm going to do is negative 4 to 0, this part, fx dx, because I know this value, right? And then plus 0 to 4 fx dx, right? Now I will plug in the value of this part and that part from the given. So this is 21, this is 21, this is 5, right? So 21 plus 5 is 26, right? So what is 26 times 3? So 26 times 3 is, so let me write that, 3 times 26. This is 78. Yeah. So 26 times 3 is 76. So this is 3 times fx on this is basically the 78. So 3 times area under this curve and that curve between negative 4 and 4 is 78 units, square unit basically, because it is the area, right? Alright guys, thank you.